Hi everyone, this is Nick. Today I'm going to be talking about l33teral, which is a library that I wrote that is on the approved library list in the Append to Standards and Practices repository. If you're interested in this library after this video and you want to do a source dive or take a look at the README, you can go to github.com/nicholascloud/l33teral. So I'm going to jump over to some code and talk to you about what this library is and why it's useful. So I was working on a project not long ago where I had to deal with some very large object literals that were being passed to my code from a service bus. And these objects were generated by a Java backend, so we had no real control over the shape of these objects or what kind of data they would contain. And so we ended up getting some inconsistent object schemas where we would expect them to have properties that they wouldn't have, or they would have extra properties that we didn't expect. And so there was a lot of ugly code that kind of had to deal with this, and I wanted a way to deal with these inconsistent object literals with a single API. So I came up with the idea for this library. For this example, I'm going to be using this rather large object literal, which represents a brewery here in St. Louis called Schlafly. And this has a bunch of different information in it. We have their address information, the states in which Schlafly distributes their wonderful beer. We have some information about the beer itself. For example, their year-round offerings and their core seasonal offerings. There's some other beers that we're not going to include in this collection of beer, but that Schlafly would offer. There's families of beers, colors, and flavors under which these beers are all classified. So this represents kind of a large chunk of data that we would get and have to deal with at some point in our application, and it's pretty realistic. You can see this if you built an application dealing with popular breweries. This is the kind of data that you would expect to get back. So in this example, I'm using l33teral in Node.js. You can use it in the client as well. You can import it into the browser and use it as a global, or use it with require.js. But for this example, I'm just using it in Node because it's a little easier. So I'm importing the package here into my script, and I assign it the alias leet, which I like to do. It's just shorthand instead of having to type out l33teral all the time. Also, I'm importing my brewery object, so this is what we'll be working with as our data. Let me split this so we can see both data and code. There we go. So in my application, let's say, and this is a scenario that I would run into often, we get this data back, and sometimes this data would have the array of special release beers, and sometimes it wouldn't. So in the application that I was working on, which didn't have anything to do with beer, by the way, this is purely example code, but similar scenario. I would see a lot of code like this. If brewery and brewery.beer and brewery.beer.special release, then do some logic. Okay, so we're using a compound and expression to evaluate whether or not special release actually exists in our object graph. Remember, the data we're getting back from our APIs or from our Java endpoints is not really consistent. So in order to protect ourselves from potential errors in JavaScript, we have to do this kind of checking. Another thing what I would see would be this exact same thing but done with assignment. So var specials equals brewery and brewery.beer and brewery.beer.special release. And this compound expression would be evaluated, and if special release, if we got this far, then the value of special release would be assigned to the specials variable. So this gets really ugly really quick, especially as your object graph grows and you have deeper and deeper nested objects. So I created l33teral to kind of help deal with this problem. So the way you use l33teral with an object literal that you want to work with is you're going to wrap that object in the l33teral API. And we do this by simply assigning a variable. In this case, we'll just reassign this to brewery and pass the original brewery literal into the leet function. And now brewery is a literal object with the literal API. And if we ever want to get back to our original data, we can just say brewery.obj. And this property will actually point to the original object literal that we're going to be working with. So how can we do this with literal and make it a little bit cleaner? Well, if we want to test for the condition of a path in an object graph, and say if brewery.probe beer.special release. And probe will tell us, return a Boolean value, if this object graph exists on our data. So notice a couple of things here. One, we don't have to test for brewery. If for some reason brewery is undefined or null when we pass it to leet at this point, all of the functions that we try to use to manipulate the object graph or know something about the object graph will return false or whatever, throw an error or whatever. So we don't have to specify brewery as the first part of our path. We just start at the property that would be under brewery, which is beer. So probe looks at this path and says, well, if this exists, if there's something at the end of this path, then return true or else return false. So you can already see how this is a lot shorter of a comparison to the compound and expression that we were using up here. For assignment, we do something similar, only we use the tap method, and we'd say beer.special release. And you can see how that's substantially shorter than the compound and expression we were using here. Now tap, unlike probe, tap will throw an exception if special release does not exist, or actually if anything along this path does not exist. So in this case, special release over here is not actually a property in our object graph. So we're going to get an exception when we attempt to tap it. If we don't want an exception, which is usually what we don't want, we want some kind of default value, you can pass in a second argument, which will end up being the default value if anything along this path fails to resolve. So for example, if beer wasn't actually a property here or was null or undefined, you would get, actually it would return if it was null or undefined, but if beer didn't exist as a property, you would get this array instead. Same with special release. So in this case, we'll end up getting an empty array because special release doesn't exist. So it gives us the default value. Now, sometimes what we want is to know if an object graph has multiple properties. So there are a couple of variations on probe that we can use that will help us determine that. So over here in our beer collections, let's say we want to know if we have both special releases and year-round beers in this set of data. So I can do brewery.probe all beer.year-round beer.special release. What probe all does is it says if both of these exist, return true. If any of them do not exist, return false. So in this case, it would return false because special release doesn't exist. And we're asking it, do all of these properties exist? Or all these paths exist in the object graph? If we want to determine if any of them exist as opposed to all, we can do the exact same thing, but use probe any. And pass in these two paths. And in this case, probe any would return true because year-round does in fact exist. Now, one interesting thing we can do with our paths is we can also enter arrays through their numeric keys. So if we go over here to our data and we open year-round, we can see that there's a number of beers in here, and that year-round is actually an array. So let's say I want to test to see if year-round has an item in it. Just one will be sufficient. So if there's an item at index 0, then we know that we have beer. So I can use the standard probe method, and I can say beer.yearround.0. And if there's actually an object in year-round, actually technically if there's a property called 0 on the year-round object, which is how arrays are structured in JavaScript, this will return true. So I can actually get to or determine if there is an element in this array. I can do the same with tap. So year-round dot 0. And in this case, it's an object that I want back, not an array, so I'm going to default it to an empty object literal. I'm going to call this the beer. So in this case, year-round actually does have elements, and the first beer is the pale ale. So the value of the beer over here is going to be the pale ale, which is pretty awesome. So let's clear some of this out and show that this is actually working by outputting some stuff to the command or to the console. So I'm going to clear out some of this. So the first thing we'll do is we'll show that probe is actually working for this path. So we'll do console.log. And because beer.yearround.0, the first one should exist, we should get a true back. And we do. Output's true. Awesome. So what happens if we attempt to do the special release? And we'll try to get the first beer at special release. And remember that probe will fail if anything along this path doesn't exist. So because special release doesn't, it's going to fail at this point. It's not going to fail at getting the first item in this array because the array itself doesn't exist. And we get a false. Awesome. Let's comment that out. Let's try probe all. And so we have two paths here, beer.yearround, beer.special release. We know that special release doesn't exist, so probe all is going to try to enforce or try to determine if every path specified here exists, and because one of them doesn't, we should get false, which we do. Probe any, on the other hand, is going to look at all these paths and ask, well, do any of them exist? And because year-round exists over here in the object, and because it's not undefined, or just because the property exists, this should return true. And it does. If we eliminated special release, ran it again, still true. If we change this to special release, run it again, now it's false. Essentially doing the same thing that probe would do. All right, so let's use tap here, and we have the beer that we're going to get back. We run this, and we should get the pale ale, which is exactly what we get. Beer.yearround.0 gives us the pale ale. If we do special release, because that doesn't exist, we should get back our default empty object, which we do. So what happens if we don't specify default? We're going to get a nice ugly error. Now there's some interesting things that this error will show us. So let me do a try-catch block around this. Try it again. So this gives us some interesting information. This error is of type graph error, which is an internal type to the literal library. But it tells us a few things about what happened during this operation and why it failed. The operation that was occurring was tap. That's the method we called. And we're failing at beer.specialRelease. So you can see that it didn't even try to evaluate the index 0. And it tells you exactly what part of the path it failed at. So this is also a good way to test your objects. If they should have some path, and you are trying to prove that they don't have it consistently, you can catch this error and write out this output, and it will tell you exactly what part of the path is missing, where the failure occurred. Any of the methods in literal that throw an exception will have this information in it. So it can be really handy for debugging your data, especially if it's a closed system and you don't have control over things. Maybe you introduce code in between your calling code and the API that fills in these gaps if they don't exist or something like that. So literal has a couple of other methods that are useful for pulling data out of your object literal in a custom way. So let's take a look at those. Get rid of some of these windows, lines of code. Keep our Elite Brewery up there. Let's take a look at our data. So let's say I'm putting together a website for beer lovers, and I want to show beers that are in the golden family, and I also want to show beers that have a sweet flavor. So I'm tailoring this to specific tastes, and I'm doing some manipulation here. I want to send this data to the client. I don't want to send this whole gigantic data object. I just want to send these two pieces of information. Literal can help us collect those pretty easily. So the first thing we're going to look at is the collect method. So we'll say beers, bar beers equals brewery.collect, and we want colors.golden and flavor.sweet. And if we look at what this does for us, beers, in the output, we can see that it gives us an array. Beers is an array, and it has two elements. The first element is the tap result from colors.golden. The second element is the tap result from flavor.sweet. So what collect does is it basically iterates over each of these properties, each of these paths in the object graph, and it calls tap on them, and then it puts them into an array in the same order that you specified in the arguments to collect. So what happens if we have a property that doesn't exist? Let's do flavor.sour. We don't have any sour beers. The third argument, or the third element in the array is going to be undefined. So this doesn't throw an error. It just simply puts undefined in place of anything it cannot actually find. So it suppresses the error from tap. So that's how we do, that's what collect does for us. Now in this case, we're returning this array to the client, and now the client has to know that the ordinal position of these elements. So it has to know that at beers at element 0 represents the golden beers. Beers at element 1 represents the sweet beers. And using ordinal positioning for data is tricky at best. So there's another thing that we can do. Instead of using collect, we can use extract. Let's change this to extract. And now let's see what kind of output we get. So with extract, you get an object instead of an array. And the properties of the object are the paths that you pass in to the extract method, and their values are the data that extract was able to tap from the object. So this is a much easier way for the client to work with the data. So when you pass this back to the client, they can say, object.colors.golden and get this array back, flavor.sweet, and we can see here flavor.sour, because it couldn't find it, it simply makes it undefined. So this is how extract and how collect work. Sometimes an array is fine if you're wanting to pull out some primitive values that you're going to do some calculations with later maybe. Maybe you want to pull out all the IBV values of the individual beers, or ABV values, and calculate an average or something like that. Well, an array would work perfectly fine for that. But when you're pulling out sections of this object that you're going to reference later, usually extract gives you a much stronger object to work with. So what about adding and removing data from your object? Literal lets you do this as well. So let's say in our beer collection here, since we don't have special releases, we want to go ahead and add that. Remove this code. But in this object, because the schema is so flaky, we're not sure if the beer property actually exists. So we can use literal to help us actually add a property at any point along a path in this object. And it will create any of the paths that don't exist for us. So for example, if I commented out this entire block called beer, so that none of this beers were present, and the beer property itself isn't present, we can see that that is undefined simply by writing it to the console. And this should throw an exception, which it does because beer no longer exists, commented it out. So what we want to do, though, is we want to add special releases to this schema. And presumably we've gotten documentation about how the schema, quote unquote, should look, even though it doesn't look right when we're dealing with the object. So what we can say is brewery.plant beer.special release. And this is going to be an array, and we're going to have one beer in this array. Its name is going to be export IPA. Now we'll log not only beer, but we'll tap special release, and we'll see what it gives us. And you can see we get that array back. So what does plant do is it walks this path, and any property that doesn't exist on this path, it will create it, and then it will keep going, keep making objects as it goes along, and then at the end of the path, it will add this object here, which is the array. Limitation to this is that, let's say we wanted to do special release.0, and we just made it an object literal here. You would think from our previous experiences with using the dot number in the path applying to arrays, you would think that literal would make this an array, but that's actually not the case. You can see that literal makes this an object with a property called 0. So this is a limitation to literal. It assumes that all the properties that you want to create with plant belong to objects, object literals, not arrays. So we've added our special release collection. Let's uncomment our beers again. So now we'll have both year-round and seasonal and special release. Year-round, core seasonal, and we're adding special release here. So we'll have those 3 arrays present in our beer object. So what happens if we want to remove something on an object graph? Let's say, for example, we want to remove year-round. Well, come down here and say brewery.snip beer.year-round. Brewery.tap beer.year-round, and this should throw an exception. Because what snip does is it will walk this object, this path, and it will remove the last item, the property at the end of the path, from the object graph. If any of the path parts here fail, if it can't find any of these, it will throw an error. You can actually turn that off by just passing in a Boolean value at the end to suppress the error. So let's say that you just want to make sure that year-round doesn't exist on this object. You don't care if it's there right now or not. You just want to make sure it doesn't exist. So if it's not there and you attempt to snip, it's going to throw. So we want to tell it, no, suppress the error. We don't want it to throw. But we'll leave that true off because we know in our data over here that year-round actually exists. So let's see what happens. Yep. So we did a tap on year-round, and we get the exception. Nope, doesn't exist. So let's suppress the error. Oh, we suppressed the error for snip. We didn't suppress the error for tap. So with tap, you can also, we need to specify a default object, actually. And we get that default object back because year-round no longer exists because we snipped it. So this is a way to kind of target items at the end of an object path for removal. Now let's say we want to remove everything along an object path. In other words, we want to go to the end of the object path, walk backwards, and remove each property so that you can basically do a deep delete on something. So instead of using snip, we would use purge. And this would start at the end, and it would remove the object at year-round, and then it moves up to beer, and removes the value of beer, and it would keep going along the object path until it couldn't remove anything any longer. The same error rules apply as snip, where if it can't find part of the path, it will by default throw. But you can suppress that as well, so that if it's backing up along the object path and it can't find something, you're okay. Actually, the way this works is that it looks for all the properties first. So it wouldn't even delete anything if it couldn't find something in the path when it tries to look for it. So it would throw before it attempts any deletes. But we can suppress that error. So let's clear the console and run this and see what the value of beer is going to be. So we see that it's an object, and we see that our special releases property is here. And if we scroll up, we can see that the core seasonal collection is here, but the year-round is not. Now, the reason that the beer property still exists is because purge will only clear objects that have no other properties. So once it detects that an object on the path, as it's backing up through the path, has additional properties, which in this case it does. Beer has the properties core seasonal and special release. Once it detects that, it stops the purge process. So it's more of a cleanup type of thing as opposed to nuking the entire object graph from orbit. So if we go over here and we were to remove core seasonal altogether in our data, and we commented this out so that we were not adding special release, that means year-round is going to be the only collection in beer, in the beer object. So if we run this again, we can see that beer is in fact an empty object is what we specified as the default. If we remove that, this should throw an error, which it does, because beer no longer exists. Once it cleared out year-round, beer is an empty object. It'll clear out beer, and that property doesn't exist in the object graph any longer. So this is the basic use of literal. Like I said, if you want more information, you want to view the README, look at the source code, please feel free. Again, github.com/nicholascloud/literal. Remember the use case that this was designed for, manipulating object literals, specifically data. It's not designed for working with normal JavaScript objects that have functionality, that have functions, things like that. It's just strictly a data operation library. And it was designed to fill a specific gap in dealing with data that we did not have control over on our project.